this webcast, we're talking about the journal assignment for Unit 2. In this project, you'll be looking at the motion of a snail. I recommend that you first watch the full video, it's short, of the snail moving. Notice the information given to you by this video. There is a blue ruler next to the snail, and the right-hand side of the ruler is a scale labeled in centimeters. The left-hand side is measured in inches. And we definitely want to measure in the metric system, and so we're going to use centimeters or millimeters to measure. Notice that each centimeter, like the distance from 5 to 6 centimeters, is broken into 10 parts. So each one of those small increments is identifying a millimeter. And we want to measure to the nearest millimeter. The time information is given over on the right with that little clock. So the first thing you'll need to do is identify your independent and dependent variables. We're studying the motion of the snail, and we would like to find an equation of motion for it. So remember, there's a strong convention for always placing the time variable on the horizontal axis, and so that would tend to make us use the time variable as the independent variable. Recall the tumble buggy lab? In order to have an equation of motion, we want to give an equation that tells us what the position is as a function of time. So before you start getting data, you'll need to think about how you will measure. And the first thing, I think, is to choose a reference point on the snail for measuring its position. So, you don't necessarily have to choose the leading edge, the little antenna at the top of the snail, or the tip of its tail. Notice that both the antennae and the tail, they tend to move to the left and right as the snail makes his progress. And so I would recommend choosing something that is a little more constant in relation to the ruler. And I think either the front edge of the shell or the back edge of the shell are features that you can see very clearly all the time, and they don't tend to move left or right. Now you'll need to write a procedure, and I mean list several steps or bullet points of how you intend to measure. And I want to caution you to be sure to measure the position over the full time range. The video shows you 30 seconds worth of motion, and you need to collect data over the full 30 seconds. Now I know that in the table that I gave you in the template for this assignment, I think it has 10 or 12 rows. You can certainly collect more data than that. In fact, more data is better, but if you collect the first 10 data points over the first 10 or 11 seconds, that's not good enough. You have to have data over the full time range, all the way out to 30 seconds. Okay? A few considerations. So you can change the playback speed if you want to slow it down. You go to the gear for settings and then change the playback speed. I'm showing a picture of that over there on the right. It's not really necessary to stop the video at precisely even time intervals. Like, you don't have to measure it at each second exactly. You could take a data point at 0.6 seconds, and then 1.2 or 1.3 seconds, and then 1.9 seconds, 2.4 seconds. But the important thing is to record the accurate time when you take a position measurement. And you must measure at least 10 points, but the more the better, really. And if you want to, just add rows to the table in the template and take more data points. More is definitely better. In order to see clearly how your reference point lines up with the blue ruler, I recommend that you take one of the clear straight edges that are on the tables in the room and hold that up to your screen. Make the video, take up the full screen, and then hold that ruler up so that you can really see clearly how the feature that you're using lines up with the ruler. You need to make a data table before you take measurements. And so at the top of that data table, it's not labeled. You need to put a label that identifies both the variable name and the units. And you definitely want to put the independent variable in the left-hand column. Okay. And then after you've collected data, you'll need to make a scatter graph. So we will have some time to work on the graphs next class, but if you want to go ahead and start that, then there is a folder with graph paper on the small desk, and there's also a PDF file of graph paper in the Schoology page. You could download and print that. So be very careful with the scale that you choose. So it's a big requirement to make the data spread over nearly the full width and height of the page of paper. And to do that, I really recommend that you label the position scale in millimeters or tenths of centimeters, the way I've done here. And notice that my position scale does not start at 0. My measurements were all in the range between 5 and 7 centimeters, and so that's how I labeled my position scale, so that my data points spread out as far as possible. That also made it easier for me to accurately plot these points. I'm not having to estimate as much, like the difference between 5.1 and 5.2. Here's an example of what you should definitely not do. Okay, do not do this. In this graph, the position scale is labeled in whole centimeters, and therefore each data point required a lot of estimation because they had to differentiate between 5.1 and 5.2 and 5.3 centimeters, and there were no real grid lines or anything to help with that. Also, this scale is numbered from 0 to 7, and so all of the data is compressed into a very narrow row of the paper, and so we're wasting a lot of the page, and also it will make it difficult for us to get an accurate slope.